Hey there, class. Hope you're having a good day so far. Sorry, I gotta turn off Zoom here really quick on my other computer. Let's go ahead and we're doing 1.1 today. First, real section of the year. You want to follow along in your packets and take notes and try the problems when I tell you to pause the video and stuff. And I'll probably break this up into smaller videos so you don't have to watch everything all at once. But we're going to get into it. So this is 1.1. The name of the lesson is Variables in Algebra. And our essential question is, what is a variable and how is it used? So what I'm going to try to include in most of my lessons is a warm-up. So it says fraction review, convert this mixed number into an improper fraction, multiply these fractions, and add these fractions. So why don't you guys go ahead and pause the video and give these a try. All right, welcome back. Converting a mixed number to an improper fraction. What's the shortcut? We're going to do what times what plus what? 4 times 5 plus 3. 4 times 5 is what? That's 20, and 20 plus 3 is 23, and that's all over. Keep the denominator the same. Easy as that. That's all you got to do. All right, and then it's multiplying fractions. No big problem. Top times top over bottom times bottom. So for this one, we can approach it a couple different ways. We can just multiply straight across. What's 2 times 9 going to be? That's going to be 18. And what's 3 times 6? That's also 18. What's 18 divided by 18 going to be? That's going to be 1. Another thing you could do, I'm going to rewrite it over here. And this might seem like a lot more work than doing it the other way, but it can be less work if you're working with really big numbers here, okay? So what you can do here is you can reduce vertically. You can reduce by dividing by numbers. You can reduce diagonally. But you cannot reduce side by side. Do not do that. That's not how we do this, okay? So let's look vertically and see if we can reduce these at all. So 2 and 3, is there a number that goes into 2 and 3 nicely that we can divide both of them by? Nope. What about 9 and 6? Is there a number that goes into 9 and 6 nicely? Yeah, hopefully you said 3, and 3 goes into 6 how many times? Twice. 3 goes into 9 how many times? 3 times. So now we have 2/3 times 3 over 2. And now if you multiply straight across, you're going to get 2 times 3 is 6 over 3 times 2, which is 6. See how that already made it kind of nicer numbers for us? But we can go even farther. We can go cancel diagonally now. So looking at this, is there a number that goes into 2 and 2 nicely, diagonally? Yeah, 2 goes into 2 how many times? 2 goes into 2 how many times? All right, what about 3 and 3? Is there a number that goes into 3 and 3 nicely? Yeah, 3 goes into 3. If they have the same number, they each go into each other nicely. So 3 times 3 is 1, or 3 goes into 3 one time. So now we have 1 over 1, times 1 over 1, which equals 1 over 1, which equals 1. So this was kind of a weird problem that made it a lot harder, a lot more extra steps. But when you're working with really big numbers, it makes it easier to deal with numbers that way. And then it's when adding up or taking away fractions, don't be a hater. Bottom numbers have to be the same common denominator. So we want to find the least common multiple of 2 and 7. So you start with the bigger number, which is 7. Does 7 divide by both 2 and 7? Nope, 7 doesn't divide by 2. Then I'm going to count up by 7. After 7 comes 14. Does 14 divide by 7 and 2 nicely? It does. So that's going to be our least common multiple. That's going to be our least common denominator. So 2 times what's going to be 14 over here? 7. 7 times what's going to be 14? 2. So now we have 7 times 1 is 7 over 14, plus 3 times 2, which is 6 over 14. And what's 7 plus 6 going to be? That's going to be 13 over 14. And there's our answers for that one, okay? All right, I think we're going to split this up into maybe Maybe we'll do three sections for this thing here. So I think we're going to finish this bottom section here, then we'll do another video for the next section, okay? All right, next thing, variables. You guys heard the word variables before? You guys know what goes in the blank here? What do you think? A variable is a letter used to represent one or more numbers. Did you get it right? Hopefully you did. If you didn't, that's okay too. It's not a problem. It's what we're learning for. So this is, what are the four main operations that we know? Our variable expression is the collection of numbers, variables, and operations. And what are the four main operations that we know? Well, we know operations would be something like addition. So I'll give you the first one. What are the other operations that we know? Addition, we also have subtraction. And the other two, we have multiplication, or you can use a dot for this. What's the opposite of multiplication? We also have division, or you can do like A over B. Okay, examples of expressions. So I want an example of an expression using a variable, which is just a letter, and a number. So I'm going to do x plus 4 as our example of our first expression, and that literally means x plus 4. Why don't you guys go ahead and pause the video, see if you can come up with some other examples of expressions to fill in the blanks here. Go ahead and give it a try. All right, for the subtraction one, I just put z minus 5 would be an example. Z minus 5. What'd you get for multiplication? Now, I'm curious how you guys would have written this one. So there's three ways you could have written this. I did 10. So the way I wrote it first was 10c, which is the most appropriate way to write this. You could also do 10 dot c or 10 times c. But we kind of get away, I want you to kind of get away from this last section here, this last way to do this. And do you guys know why? Why do we want to get away from the x-looking, x-looking, thing for multiplication? Well, we use x a lot in algebra. So when we use x as for multiplication, it's like xx. It gets kind of confusing. You know what I mean? So this literally means 10 times c. So what I would encourage you to do is try to get in the habit of just smushing them together like this. That usually means, usually we put the number in front. Number goes in front, and then we just smush them together 10c instead of 10 times c or, the little x there, okay? All right, last one we did, I just did 16 over b. I wish I could get your input on this stuff here, but it's kind of a one-way video, so obviously that's not going to work. All right, and this literally means 16 divided by b. Okay, we're going to pause the video there. We got 2 more sections to fill out. And we will, we'll probably call it a day.